So we've been talking about solutions and what happens to specific compounds when they're dropped in water. Do they dissolve? Do they dissociate? By how much? By how little? Do they conduct electricity? Etc., etc. Now we're going to move into quantifying, measuring with numbers those same solutions. So the way we do that is by measuring concentration. And this should be familiar, slightly review. There's a little bit of new material that will be in this video, but we'll need to have this as a basic understanding going forward. So let's say you got a glass of water, you dump in some sugar. You want to make some sugar water. Okay? At the molecular level, what that looks like is we have some water in here, and I'm not going to draw the water molecules just to make it easier on us, but what we do is we have that, let's say it's Na, well, we said it was sugar, but let's just say it's salt, NaCl that starts. We know that's a strong electrolyte, ionic compound. It's going to dissociate when we drop it into solution. So we're going to form our Na plus ions and our Cl minus ions. And they're in a 1-to-1 ratio because the formula has 1 sodium per 1 chloride ion. Now what we can do, depending on the volume, how much water there actually is, and the number of ions, we can measure the concentration. There's a variety of ways we can measure concentration, but the main way that we're going to measure concentration is with something called molarity. And molarity is equal to the moles of solute divided by the volume of solution. Okay? The volume of the total solution, not just the solvent, but the solute and the solvent mixed together. The units for molarity are usually abbreviated with a capital M, so if you see something that says 6 capital M, that means 6 molar is how we pronounce it. This solution has a concentration of 6 molar, which means for every 1 liter of solution, there are 6 moles present, very concentrated. So let's do a couple problems to see how we can apply that, and then we'll use this knowledge in class to do more in-depth, higher rigor problems. So number 1 says, calculate the molarity of a solution made by dissolving 3 moles of NaCl in 6 liters of water. So our unknown is asking us to figure out the molarity. We're given 3 moles and we're given 6 liters. Well, I know molarity is equal to the number of moles divided by the moles of solute divided by the volume of solution. So let's see, how many moles of solute do I have? I got 3 moles of solute, and I have 6 liters of solution. So the molarity of this sodium chloride solution would be 0.5 molar. That's the concentration of this solution. Pretty simple. Let's take it a step up and incorporate our stoichiometry concepts. Number 2 asks, what is the molarity of a solution that is made with 23.4 grams of sodium sulfate in 125 milliliters of solution? So there's a few things here. One thing you should always do when you're given a compound and its name, rewrite its name in the correct chemical formula. So sodium sulfate, you got to remember SO4 is sulfate. It's a 2-, so that means we have to have 2 sodium, so the formula is Na2SO4. That's going to help us because the problem is asking for the molarity, but we're given grams and volume in milliliters. So there's a couple things we're going to have to do here. Well, to figure out the molarity, we're going to need moles over liters. But our units right now are in grams and milliliters, so we're going to have to convert them. So let's get the moles first. Well, this should be second nature to you by now. 23.4 grams of sodium sulfate. So I'm going to look up the molar mass of this guy here. If I look up the molar mass added up on the periodic table, I get about 142 grams per mole. Grams per 1 mole. Cancel out the units, so this means I get a 0.1647-ish moles of Na2SO4. Milliliters, we got to convert those into liters. That's very easy. To convert from milliliters to liters, you just divide by 1,000. So 125 divided by 1,000 is 0.125 liters. So now I plug in my givens. I have my moles, 0.1647 moles divided by my volume, 0.125 liters. If I divide those numbers together, I'll get 1.32 sig figs from the problem molar. So the concentration of this solution is 1.32 molar. Right on. Let's look at number 3. How many grams of sodium sulfate are required to make 0.350 liters of 0.500 molar sodium sulfate solution? Same thing, you're given a compound, write that formula. Sodium sulfate, luckily it's the same as before, Na2SO4. Now let's think about what this problem is asking for. It's asking for grams. So if we want to make a solution that has this volume and this exact concentration, I'm going to have to measure out some mass of sodium sulfate. How much mass? Well, I know molarity equals moles of solute over liters of solution. So if the molarity is 0.5, and I know the number of liters is 0.350, I'm going to have to figure out the number of moles. So this is just algebra multiplied by 0.35 on both sides. X equals, if we do that across, 0.175 moles. But now be careful. The problem is not asking for moles, it's asking for how many grams of sodium sulfate are required. So we need to take our number of moles of sodium sulfate, 0.175, multiply it by the molar mass. 1 mole, again, this is the same compound from before, so the molar mass is 142. Multiply those across, and we get a final answer of 24.9 grams, 3 sig figs. If you needed to make this concentration of solution and this much of it, it would take 24.9 grams. Last one, a little bit different, but the same concepts still apply. So let's say number 4 says, what is the molar concentration of each ion present in a 0.025 molar solution of calcium nitrate? So again, first thing you need to do, if you're given a chemical name, convert it to the formula. Nitrate is NO3 with a -1 charge. Calcium has a 2+ charge. So we're going to need 2 nitrate ions for every calcium ion. So what this means is if this dissociates into solution, and this should be review now, we're going to get 1 calcium ion with a 2 positive charge for every 2 nitrate ions we get. The ratio is 1 calcium for every 2 nitrates. This means the concentration of nitrate ion is twice that of the calcium ion. So if the solution of 0.025 molar calcium nitrate dissociates, the calcium ion concentration is going to be 0.025 molar. Let me erase that, make it a little clearer. 0.025 molar, since we have 1 calcium ion in this compound. And the concentration of nitrate, on the other hand, since we have twice as much nitrate, the concentration would be twice the concentration of calcium. So it would be 0.025 times 2, which would be 0.05 molar. 0.50 to have 2 sig figs. So again, the concentrations of each ion just depends on the number of each ion present relative to each other. So the ratio here for calcium to nitrate is 1 to 2. So you got to have twice as much nitrate as you do calcium.